In a system with three variables, each equation contains, for example, an x, a y, and a z. As soon as there's three variables, that equation no longer represents a line, it represents a plane. So if you take a look at the first example here, we can see we've got a red plane, we've got a green plane, and we've got a purple plane. The point at which those three planes intersect is the solution to the system. We're now working in three dimensions. So an example to a solution to the system is going to be no longer an ordered pair, this is what we call an ordered triple. So we have an x-coordinate, a y-coordinate, and a z-coordinate representing the point where those three planes all intersect. Now we could end up with no solution if there's no point at which those three planes intersect, or we could have an infinite number of solutions if the three planes intersect on a line. But for today, we're going to take a look at how to solve a 3x3 system where there is one solution. What is that ordered triple those three planes intersect at? So you can see that we have three different equations here and three different variables in each equation. We're going to start by trying to eliminate one of those variables. And there are so many ways you can go about this, it doesn't matter. So I could, for example, try to eliminate those two A's. I could try to eliminate those two C's or those two C's or even that C and that C. I could eliminate the B's. You have so many options. These are fun little puzzles you get to try to solve. Choose one variable and see if you can eliminate it. I labeled my three equations just to make it easier to follow what I'm doing here. In taking a look at these, I can see that by subtracting the second and third equations, I can eliminate both A and C, which would then allow me to solve for B. So I've already got the value of one of those variables, and then I can substitute B back in to either of those equations, leaving me with just an A or a C, which is what we're used to solving. I've substituted the 4 into my first two equations, and then I combined my like terms to get it simplified down. Now, if I take a look at these two equations, so this is equation 1 and equation 2, I can see that by subtracting, I can eliminate C, which would allow me to solve for A. And then once we have the value of two variables, we can substitute them into any equation. Any one of these will work to solve for the third variable. I just happen to choose one of these just because it makes it easier. This is probably the easiest one. And then when you put them together, we're going to line them up alphabetically. And so we've got the value of A, B, and C, and then we're going to verify to see if this is our solution. This is probably the easiest one, but we're going to check all of them. So if A is 1, plus 4, plus 3, we get 8. 1 minus 4 is negative 3, plus 3 is 0. 2 times 1 is 2, minus 4 is negative 2, plus 3 is positive 1. All verify this is the solution to our system. Take a look at my next one. I can see that I've got X, Y, and Z, and right away I notice that these two Y's are probably the easiest to eliminate. I can add those two equations together and get rid of my Y. By bringing together equations 1 and 2, we've eliminated one variable. We have now just an X and a Z. I'm going to see if I can somehow get the third equation in here. Is there a way that we can eliminate this y to also get an x and a z, which is what we're used to solving? So again, it doesn't matter, I could use either of these, but maybe let's go with number 1. So if I multiply this whole equation by 2, I can cancel the y's and then bring 3 into the mix here. Okay, so my goal is to get the two variables x and z and also to bring all three equations in. So I need to focus on 3 because I haven't already dealt with that. And so I'm going to take equation 3, and in order to eliminate y, I multiplied every term in the first equation by 2, added the 2 together so that my y's cancel, and now we have two equations with two variables, which is what we're used to solving. And then again, I'm maybe going to multiply every term in the second equation by 3. That will allow me my z's to cancel, and I can solve for the value of x. I was able to then subtract these two equations, all that work, but we have the value of x. So now I would look for an equation that contains x and only one other variable, so I can solve for the other variable. Here's one. Okay, so let's maybe put an x in here, and that will give me the value of z. 9 times 1 is 9. 12 minus 9 leaves me with 3. Now that I've got z, we can choose any equation and solve for the y value. I just happened to choose the third equation, so I substituted in the value of x and the value of z, and then solved for the value of y. Line them up alphabetically in our ordered triple, and then verify. So into the first one, if x is 1, we have 4 minus 2 is 2, plus 3 is 5. That verifies. This term, if x is 1, is 2. Now, minus a negative is positive. So we have 2 plus 2 is 4, plus 2 times 3 is 6 is 10. And then we have 1, negative 2 times negative 2 is positive 4. So we have 5 minus 3 is 2. All three verify. We have the solution to our system. As you can see, these get quite cluttered quite quickly, so keep your work really organized and labeled so we can see what you're doing. Take a look at your three equations. Is there a variable you can quickly eliminate? I see right away if I combine the first and second equations, subtract them, I can eliminate P. 1 and 2 are on the board. Is there a way that we can bring in the third equation? And at the same time, can I get it down to Q and R? So is there a way to eliminate P? I'm going to need to get a 2p so that my p's will cancel. So I'm going to take this third equation, multiply every term by 2, and then choose either 1 or 2. It doesn't really matter. I just happen to go with 2 and then minus the third equation, and then we can get it down to q and r. So now we have two variables. We have a q and an r here. We have a q and an r here. We can now solve the way we're used to solving. I chose to try to eliminate Q because I have a 2 and a negative 7. I multiplied every term by 7, every term by 2, and then I can add those two equations together, and this reduces down to 3/4. So now, all that work, but I got the value of R. I'm going to substitute R either into this equation with only two variables or this one to solve for Q. I happen to choose this equation, so we substituted in the value of R is 3/4, we solved for Q, and now you can choose any equation to solve for the last variable, P. And once we do, we have our ordered triple, which you can then verify. So quickly to recap, we're going to choose a variable we can quickly eliminate, try to bring the third equation in, eliminate the same variable, get down to two variables, and then we're back to what we're used to solving. Have some fun with these. Enjoy the process.